You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. To answer this question, let us try to have this unit circle here. This is considered to be a unit circle because the distance from each of the points on this circle from the center is just equal to 1. Let's say this point here, and this would be our center. The distance of that would be just equal to 1 unit. If we're going to pick a point here, the distance of that is also equal to 1. Even a point here, connecting that to the center, the distance of that is 1. Hence, it's called a unit circle. The idea of a unit circle also connects to the problem, because to determine whether which of these 2 points or are these 2 points, a point on this unit circle, this should satisfy the idea that the distance of that point to the center is just equal to 1. Now, looking at this perspective, just for this idea here, okay, we don't know what this point is. If you're going to come up with a perpendicular line of that from the horizontal line here, we could have here a triangle, but not just any triangle, but more specifically, we have here a 90-degree angle, hence it's a right triangle. With this side being the opposite of a 90-degree angle, this is our hypotenuse. This would be one of its legs, and from here to here is also one of its legs. This is actually the x value of this point, and this vertical here is the y value of this point. For this point to be a point on this unit circle, this should satisfy the distance of this hypotenuse. And we know using Pythagorean theorem that the distance of the hypotenuse, or the square of the distance or the length of the hypotenuse, is equal to the sum of the squares of the legs. In this case, we have here our leg is x squared plus the other leg is y squared. This must be equal to 1. Okay, being again, or 1 squared. But of course, we know 1 squared to be 1, so it's just 1. So these points here, the points that you can see in this unit circle, satisfies this equation. If it will not satisfy the equation, then a given point is not a point on the unit circle. So we are going to use this formula to solve for this. Okay? We need to satisfy or show whether this equation is satisfied by each of the points there before we can say that they are actually points on the unit circle. And by the way, even if we're going to try this here, and I'm going to come up with a vertical line here, let's say for that, and of course this would be its horizontal line. This is still x of this point, though negative side. This is y of that point, though negative here. This is still 90 degrees. It still follows the idea of the Pythagorean theorem here. This would be our hypotenuse. The square of this is equal to the sum of the squares of x and y. So let's start with point 1. Our point 1 is 1/3, and square root of 2 over 2. Let's try if this would satisfy the equation. Of course, this being our x and this being our y. So let's check if we're going to have x squared plus y squared is equal to 1. So we will have here the square of 1/3, okay, plus the square root of 2 over 2. Okay. Is this equal to 1? So question mark here because we are verifying. So we have here the square of 1/3 is 1/9 plus the square of 2 is just 2 over the square of 2 is 4. And you have here question mark whether it's equal to 1. Using LCD, we have here 36. Okay. 36, and then we have here divide by 9 is 4 times 1 is 4. 36 divided by 4 is 9 times 2, 18. Plus, you will have here question mark 1. Of course, you will have here a result of 22 over 36, which in lowest terms is divided by 2, 11 over 18. And this is not equal to 1. This would mean point 1 is not a point on the unit circle because it doesn't satisfy the equation. Okay? Now how about point 2? Our point 2 here, let me write it here. Our point 2, okay, is a combination of 1/2 and square root of 3 over 2. Again, this would be our x. This is our y. So once we substitute here, you will have the square of 1/2 plus the square root of 3 over 2. Okay. Is this the same? Question mark. Or is it equal to 1? The square of 1/2 is 1/4. Square of 1 is 1. Square of 2 is 4. Plus the square root of 3, that's square root of 9 or 3. Square root of 2 is 4. So we have here question mark equal to 1. We will have here 4/4, which is equal to 1. We are now verified that this is equal to the right hand side of 1. This would mean point 2 is a point on a unit circle, on this unit circle. Okay, so this is how we verify whether a point is a point on the unit circle. Our point 1 is not a point on this curve. It might be because it's 11/18. That's actually less than 1. So it's a little bit in the interior on this circle. Okay, but for our point 2, it's exactly a point on our unit circle. Thank you for watching.